Playing music can give us a subjective idea of what the speakers are doing, but I want to do it a little bit more scientifically, so I'm going to run in a signal generator and sweep that signal just to see what that sounds like. Pretty annoying. So what I'm going to do is actually just adjust the frequency and see where the 3 dB points are for the speaker at the low frequency and the high frequency. I don't think I'll plot a full Bode plot, but I just want to see where its low frequency tails off and where its high frequency tails off. And I'm going to use the microphone output to show me when that frequency amplitude reaches its halfway point. This is 1 kilohertz, and I set up the 2 traces to be about the same amplitude. So the lower trace is the speaker signal on the output, and the upper trace, the yellow trace, is the microphone monitoring the speaker. So at this point they should both be well within their bandwidth. Here we are at 250 Hertz, which is where the microphone signal has dropped or cut down in half, and it's showing that the speaker response is dying off at 250 Hertz. This looks like it's the upper end at 9.6 kilohertz, where the microphone amplitude is tailing off to about 50% of its nominal value at 1 kilohertz. This is this plastic speaker cone at the same 9.6 kilohertz. It's much lower amplitude. It's almost inaudible. This plastic speaker cone hits its 3 dB point around 7.9 kilohertz, quite a bit lower. This is the plastic speaker cone at 300 hertz, which seems to be its lower frequency limit, and that's worse than the other one as well. So not only is it worse at the high end, it's worse at the low end as well. This plastic speaker cone also has some funky resonance at 1 kilohertz, so it's not as good a speaker as that good old paper cone speaker. There's no way these speakers are tracking a square wave. The trace on the bottom is the actual square wave coming out of the signal generator. The output to the speaker is the green signal, which has lost some low frequency because it's AC coupled. Boy, that speaker's a long way from a square wave. You can see some resonances in there. Up at 4 kilohertz, all we're getting is the fundamental. The harmonics are all gone. And by the time we hit 8 kilohertz, it's pretty much done. I'm going to try the other speaker. The paper speaker looks pretty much the same. Yeah. Also has some peaking resonances, but not as bad. It almost looks like it's trying to be a square wave. No, it's not clear what's oscillating here, whether it's some artifact of the amplifier or the speaker or... But you can see the amplifier's not doing a bad job with the square wave. All the way down at 200 hertz.